Hey my crazy friends, check out this exercise. We need to find the shaded area of the figure. Let's do this. We have a rectangle with sides 11 by 13. Alright, and inside we've got 6 squares of the same area. Fascinating. First, we're going to draw a line parallel to this side of the rectangle that passes through this point here. Once we do it, it'll look like this. Now let's draw a line parallel to this one that passes through this point here. We do it and it turns out like this. Perfect. Now pay close attention to this blue triangle that's appearing here. It's a right triangle because there are 90 degrees here, given that these two lines are perpendicular. Since this line is parallel to that one, we will call this angle alpha and this angle beta. Since I have 90 here, that means alpha plus beta must give me 90 degrees. Very well. Now over here, you would agree that it's also 90 degrees because it is the angle of the square. And if here I have 90 and here beta and this angle is a straight angle, so I am missing angle alpha, right? Angle alpha to complete the 180 degrees. Here we have 90 degrees and we are missing angle beta over here, and over here we have 90 degrees and we are also missing angle beta here. Here we have 90 degrees and this angle would be angle alpha. Here 90 degrees. This angle would be angle beta. We are completing angles, right? Here we have 90 degrees. Here angle alpha. Great. And look, you'll see triangles appear here. Over here there's a red triangle, here a green triangle, and here an orange triangle. This is angle alpha. Over here are the 90 degrees. And this here is angle beta. Fantastic. Now if this is angle alpha from here to here, and we have 90 degrees here, then this angle right here, look, there is a little triangle that will appear in blue as well. So if this is alpha and this is 90, then this little angle here must be beta. Over here we have 90 degrees, and if I have beta and 90, this angle here must be alpha. Fantastic. We have already labeled all the angles we need. As you can see, all the triangles we labeled are similar triangles because they all have the same angles, 90, alpha and beta, right? Now, I want you to pay close attention to this little triangle here. We are going to call it sides, x and y. So this side will be x and this side down here will be y. And the hypotenuse, which is coincidentally the side of the tiny squares, we will call it z. Alright, so what do we have here? We have a triangle x, y, z. Alright, and take a look at this triangle over here that is in green. Its hypotenuse would be z here and z there, so it is 2z. The hypotenuse is 2z, 2 times z. Very well. This means that since they are similar triangles and the hypotenuse is double that of this triangle, the other sides must also be double. Here we have beta and 90 degrees, which is x. Beta and 90 degrees. This must be 2x because it's twice the size it would be here. Alright then, if this is 2x, that must be 2y. Excellent. And the same happens here. We will have 2's again, because we are joining two sides of the squares. So this side will be 2x and this side here will be 2y. Alright, now look at the blue triangle. Its entire hypotenuse would be z, z and z. That means the whole hypotenuse is 3 times z. Let's write it down. 3z, therefore, this blue triangle we have here is 3 times larger than this blue triangle over here. This side will be 3 times x and this side here will be 3 times y. Very good. The same thing happens with the orange triangle we have here. Its hypotenuse will be 3 times z. So this side will be 3 times x and this side here will be 3 times y. You have to pay attention to the angles, right? Notice that beta and 90 is x, beta and 90 is x. Therefore, this here is 3x and not over there, right? Now let's focus on this triangle we have here in orange. its base goes from here to here, and this here is 3y. From here to here, it is 2x. So this entire side, because it is parallel to this one, is 3y plus 2x. Let's note that we have 3y plus 2x is equal to what? It's equal to this side, which is 13. So 13. Very good. Now pay close attention to this here. From here to here, notice it's 3 times y, and from here to there it's x. So we can say that 3 times y plus x is 3 times y. Plus x equals the entire side of the rectangle, which is 11. Excellent. We have a system of equations that we will use the elimination method to solve. So we will subtract this equation by removing this equation here. Very well. 3y minus 3y cancel out, and we have 0. 2x minus x leaves us with x, and here 13 minus 11 gives us 2. Excellent. We have already found the value of x. Now let's find the value of y by substituting this value into either of these two equations. I'm going to choose this one here. So we have 3y plus x, but x equals 2. And this equals 11. Move the 2 to the other side, and we have 3y equals 11 minus 2, which we know is 9. Very well. Divide by 3 and you get y equals 9 thirds. And 9 divided by 3 has always been 3. Excellent. Fantastic. We have already found the value of y, and with this we can now find the shaded area. As you know, I love using the mighty Pythagorean theorem, and this will be no different. If you are enjoying the video, don't forget to subscribe and give it a like. Let's use the powerful Pythagorean theorem on this tiny triangle right here, because I already have its sides, since this was x, and we know x is 2, and this is y, and we already know that y is 3. We can find c. Very well. Then we're going to say that the hypotenuse squared is equal to the sum of each leg squared. The hypotenuse in this case is c. So we have z squared, and this is equal to either of these two sides squared, 2 squared, 2 squared plus the other side, which would be 3 squared. Very well. We have that z squared is equal to 4 plus 9. Finally, we have that c squared is equal to 3. Impressive. We already have the value of the area of one of these little squares here. So all that's left is something very simple. Multiply this square by 6. Since there are 6 squares, we will multiply it by 6. The shaded area, ladies and gentlemen, is 6 times the area of this square, which we already know is 13 square units. Therefore, the shaded area by Pythagoras' beard is 6 times 13, giving us 78 square units. Awesome. Let me know in the comments if you liked the video, and don't forget to subscribe, give it a like, and share it so you won't miss future challenges. We'll see each other again. Bye bye.